Hi, I don't know if you can see me in this. I thought maybe I would set it up so you can see me while I'm talking, but if not, that's fine. So I am not a math teacher, and yet I love geometry. I think geometry is pure beauty. And there's obviously the most amazing equation, as you're probably aware, in geometry, which is the volume of a sphere. The thing I like about the volume of a sphere is you can extract the entire volume from one measly measurement. All you need to know for a sphere, here's a little sphere, is you need to know its radius. Look, that's the only thing you put in here. Because pi, as you should know, as you better know, is a constant. All right, so where does pi come from, first of all? Pi comes from the circumference of a circle and its diameter. It is the ratio between the diameter and the circumference. It's an irrational number that goes on forever, as is well known. It's a good way to trick computers into malfunctioning. Computer, give me the exact value of pi. And they'll never finish with that, no matter how much time they have. So let's see. So notice that the diameter of this lid is very close to 12 centimeters, right? So now, if I can do this correctly, if I could try to not rotate, I'm letting it slide. The problem is I'm letting it slide. Try to do it as exact as I can. Put my finger there. 1, 2. I can see exactly where it is, right there. And 3. So notice when 3 comes in, ooh, it almost makes it. 3 of them almost makes it back to where we started, doesn't it? Dang, it'd be really neat if pi was 3. But there's a little bit left right there, a little bit extra, and that's the 0.1415926535, 9, on forever. Okay, so it's the ratio between the diameter. It goes around the circle 3 times with a little bit of change, and that's the 0.14. By the way, you don't have to use all those fancy digits. You can just do it to the 0.14, and that's usually adequate. Okay, so now that's the ratio between a diameter and a circle. And if you really want to know the diameter, the best way to measure it is starting with the circumference, right? So if you start with the circumference, the ratio between them is pi, that beautiful Greek p, pi. So if you have circumference, you divide it by pi to get diameter. So like in other words, if I was solving for diameter, I would divide both sides by pi, it would cancel. So circumference divided by pi gives me diameter. Now that's something that people forget sometimes, and sometimes they'll use the circumference measurement for their diameter, or they'll use it even for radius, neither of which is okay. Okay, so one way to measure circumference is to put a string around an object. I've got a whole bunch of cylinders here. This is the one I'm going to use to measure wasabi peas, okay? I'm going to use this to measure I'm going to do the volume of this one. But I've got some other things like typically soda cans, sparkling water cans. This is one of my coffee tins. Okay, a lot of things are cylinders. Even this is a cylinder. It's just a very short cylinder. Doesn't have a lot of height. Now, even though I like to say width, length, height, who cares, right? Who cares which one is width, which one is length, and which one is height? Because doesn't it depend on which way you're holding it? So that doesn't matter. But in this case, it does. Because a cylinder has a height, it's very obvious. There's only one way to measure the height of a cylinder. Okay? And if you look at the formula for the volume of a cylinder, all you really need is that radius, which of course you can extract from the diameter, which you can extract from pi. Or you could go directly between the circumference and the radius. You could divide the circumference by 2 pi. Remember that the radius is from the center out. The diameter is all the way across. But we're not very good at finding the centers. You know what I mean? Like if I were trying to say, I could try to put a dot where I think the center is, like, but that might not be right. That dot, it's pretty close. But I'm not sure about that. So one way to measure diameter, there's another way to do it, is to go sort of up and down until you get the largest measurement. Because the largest thing you can get across a circle is the diameter. So that's another way to handle this. But what I'm going to do is the way I did in the lab with the string. So I'm going to take the string and put it around my little can here. Oh good, there's a little notch right there. There's a little notch it'll go right into. And then I want to get it, boom, right there. And then just to make things nice and neat, I'm going to cut my string so there's no confusion about where the marking was. Okay, and the thing about string though is you don't want to stretch it because string is a little bit elastic, so if you want to hold it, you don't want to stretch it. And here's my meter stick. So that's my circumference, right? My circumference all the way around the circle, okay? And let's see what that is. The circumference of that, and I'm doing it obviously metric, not in inches, okay, is 24.5 point, I think if I lined it up correctly, 25.5 centimeters. So that means my circumference equals 25.5 centimeters. Notice how I do a unit there, right? Got to give a unit. So now that I know the circumference, all I need, I can get the radius out of that, but I also need to measure my height. So let's measure my height. I'll write it over here. H equals, I'll just write it over here. So what's the height of this thing? And I get 16.7. Let me try to hold this. You can't really hold it, but you couldn't see how I measured that, but it's this way, 16.7. Okay, so that's my H, 16.7 centimeters. Now beyond that, with a metric ruler like this, we're not going to be able to get split millimeters. That's about as accurate as we can get. And by the way, we don't use inches. Forget about inches. Use centimeters. Okay, because remember, this is a cubic centimeter. And what we're trying to figure out is basically how many of these would fit inside there, right? Of course, you would have to stack them very neatly and cut them to fit. By the way, this little cube is just a little bit bigger. This is 1.5 centimeters on a side. But when you cube that, 1.5 times 1.5 times 1.5, what you get is 3.375. So this is almost 4 milliliters or 4 cubic centimeters, even though it's not that much bigger. But notice how it's bigger in every dimension, right? So that adds up. Okay. So now from the circumference, why don't we get our diameter? So let's divide by pi. Now remember, let me move this out of the way. If circumference equals pi diameter, then if we divide both sides by pi, right? If we divide both sides by pi, then pi will cancel right there, and then circumference divided by pi gives me a diameter. So I want to divide this number by pi, divide it by pi to get my diameter, and where's my calculator? Here we go. So 25.5 divided by 3.1415926, that's enough, equals, and you can just do 3.14. So now I have my diameter equals 8.1. I'm just going to round it to 8.1 because we're only keeping things to the tenths. Okay, it says 8.1, it would be 8.12, close enough. Okay, centimeters. So now I have my diameter, but that is not my radius. Actually, to be more accurate, I'm going to leave that on my calculator and I'm going to divide it by 2. Because remember, radius is half the diameter. So my R is equal to, I get 4.05, so I'm going to round that to 4.1. I'm just going to keep it. So now even though if you divided that by 2, you get, I'm still going to round it to 4.1 because based on the change I had on there, okay? So look, you might say, oh, that should be 4.05, but I'm rounding to 4.1. Okay, so now we've got the radius we need and we've got the height. So now we just got to plug those into this equation. So the volume of a cylinder is equal to, let me get a different color here. Volume, I like to do green for volume sometimes, is equal to pi again. So isn't it funny that we just divided pi out and then we're going to put pi back in? And you might say, oh, then why didn't we just leave it in there? And that's because if you had left it in there, you'd be squaring it. So you can't leave it in there. You have to get rid of it and then put it back. So I'm going to put pi right here, pi, and then R, okay, which is 4.1 centimeters, but squared. And then H is not squared. So notice, only the R is squared. So 8.1 centimeters. Okay, so let's work through this. And then if we've got, on the next line, if we've got volume equals, I'll keep the pi. I'll just do the squaring bit. So 4 times 4 is 16. So I expect this to be like a little bigger than 16. You know, 4.1 times 4.1. Remember, squaring is times itself. Yes, and I get 16.8, and I'm just going to round it there. But it's centimeters. Oh, we squared that unit too. Centimeters squared, right? And then when we multiply these in, here's another centimeter. Well, aren't we going to get centimeters cubed once we multiply those? Well, we better, because that's what volume is. Volume is cubic centimeters, right? Also known as milliliters, aka. And then when we multiply these together, let's just do this all in one fell swoop. The volume of my cylinder is equal to 3.1415926 times 16.8. I'm being a little silly here. I don't need pi to be that exact because these numbers are so rounded. Equals, and then times, don't forget this one, 8.1 equals, and what I get is 427.5 centimeters squared times centimeters times nothing. There's no unit for pi. Pi is a unitless ratio, okay? I get centimeters cubed. Now in scientific notation, of course, that would be 4.2, I'll write it to 8, times 10 to the what? To the what? Second, that's my volume. I've got to write it small. And don't forget, that's wrong without the units. In fact, this answer would be better than this answer without the units. You need the units. So that's the volume of this cylinder, okay? 427 cubic centimeters, that's 427 milliliters. And that kind of makes sense because volumes are very deceptive, but I wonder how it compares to this. It looks smaller, right? It's hard to get an exact count. This was another object that has kind of a cylindrical shape, a little piece of rebar, but it's dense and it fell off. Oh well, I'll leave that off. Kind of makes, even though volumes are hard to judge, this does look bigger, and this is 1,000, so it seems like it should be less than 1,000. At least I could say that. Okay, so there's about 427.5 milliliters here, or 427.5 cubic centimeters, or 4.28 times 10 to the second cubic centimeters. Okay, so that's how you do the volume. And by the way, why does that work? Why is this equation? I think it's interesting to look at how this equation derives. Okay? Because pi r squared is really just the area of the circle, right? So imagine if you had a coin, like this is a Kennedy $50. This is one of those $50, right? Well, think of that as if it were perfectly flat. You can get the area of that circle, right? Pi r squared. But then what if you have another coin on top of it? Well, then what if you wanted the volume of those? Well, you'd have to get the height this way, okay? What if you kept stacking them up? What if we had a whole stack of these Kennedy $50? I'm using these because they're bigger coins. Isn't that a cylinder? So it's really just a stack of circles. Think of it as a stack of circles. Each circle has an area, and you've got as many of them, let's say, as the height. Get it? So that's where this comes from. So it's the area of a circle times the height. Makes a lot of sense. But an even better equation, I just couldn't leave this one alone. An even better equation, an even better one than that, is the volume of a sphere. This is the most beautiful geometric equation. So since we were mentioning this, I thought I might as well cover that. So let's just do this one real fast. Volume of a sphere. Now this is 1.33, but it's really 4 over 3. It's if you divide 4 by 3, if you divide 4 divided by 3, you get 1.33 forever, right? So that's what this represents. It's not exactly 1.33. Okay, it's 1.333, as many 3's as you can fit. Pi, as you know, and then r cubed. Oh wait, pi is a constant. Pi is that universal constant. So all you really need for this is the r. Isn't that neat? So how would we get the r for this sphere? Let's do it. I'm going to flip this over. So I'm going to measure all the way around the equator of this. I'm going to assume that this is a very good sphere, not a spheroid, even though actually the Earth is a little wider at the equator. It spins out because when it was molten, it spun out, and then it's a little shorter. It's several miles shorter going from one pole to the other than going from one side of the equator to the other. Okay, so I'm just going to hold it there. Now, because for time, I'm not going to cut the string. I'm just going to hold it pinched tight here, and I'm going to measure what that circumference is. Remember, that is circumference, right? And this is a pretty good one. Woo! Pretty good. Let me make sure not to stretch the string, but get it right at the beginning. Okay, so what I've got is 62.3. 62.3 centimeters. Okay? So let me write that down before I forget. That is the circumference all the way around this. So if circumference equals 62.3 centimeters, well, as you know, if I divide that by pi, that'll give me my diameter. So 62.3 divided by 3.1415926, okay? And I get 19.8, and there's a 3 after that, but I'm just not going to write it down, centimeters, okay? So that's going, you know, through from one side to the other in that globe, right? One side to the other. And then if I divide that by 2, right? Well, now I've got my R. So R equals 9.92. I'm going to keep that 2 just to get it more accurate. Okay, usually, or I could round it to 9.9. I could have just put 9.9. I probably should have. Okay, so now let's plug that into the most beautiful equation in all of geometry. And I'm just going to write it the correct way. I'm going to write volume equals 4/3, it's actually 4/3, times pi, that beautiful ratio, times what I just put here, 9.92 centimeters. That's the only number we measured. Isn't that amazing? Okay, but not squared, cubed. Interesting, right? So first let's cube that. Now when you cube a number, that's why I kept that extra digit, because it makes a bigger difference. Times equals times 9.92 equals, so that's cubing. This times this times this, and what I get there is 975.3, centimeters times centimeters times centimeters, centimeters cubed, right? And of course, 4/3 and pi, those are the same. 4/3 and pi. That's my volume. And that's the volume of a sphere. I could put a sub s there, like I sometimes do. But isn't that beautiful? And so now let's multiply those together. So we've got this number on the calculator. See? 975.3 times 3.1415926 times 4 equals divided by 3. Don't forget that. Or you could just use, instead of that, you can always use the 1.33, which is pretty close to 4 divided by 3. And I get, did I hit equals? Yes. I get my volume. My volume is equal to 4085.2. And then what are my units? Well, this is just a unitless ratio. Pi is just a unitless ratio. It's just the units that I had here, centimeters cubed. So that would be my answer. That's 4,085.2 cubic centimeters. And if I wrote that in scientific notation, I'll do that up here. That would be the V equals 4.09, 5 rounds it up, times 10 to the 123 cubic centimeters. So this is why I don't like, if you can read that, let me see, let me hold it up closer. 4.09 times 10 to the third cubic centimeters. So this is one reason I don't like when people do that. They write centimeters and they do that up arrow and then a 3. I don't like that because it can be especially confusing in situations like this. So let me say about that, no. Learn how to do the exponents on a Google Doc or write it by hand. Write it by hand. Anyway, so I am not joking that I love geometry. It's a beautiful area of mathematics. It's just beautiful understanding of the world. And even though we were really here to talk about a cylinder, I just couldn't help myself because this is a pretty good equation. I guess that's pretty cool. But this is the best one. So beautiful. So there you go. And even if it makes Darkside mad, we're going to calculate the volume of a sphere. Okay, so I hope that helps. Bye-bye.